This tutorial is about solutions. We're going to talk about molarity and molality. So solutions are homogeneous mixtures that can be a solid, liquid, or gas. Two terms you should be familiar with. A solute is the dissolved particles in the solution. The solvent is the dissolving medium in the solution. So the solute would be salt. If you dissolve salt in water, the solute would be the salt, the solvent would be the water. The composition of the solvent and the solute are factors that affect whether a substance will dissolve. So concentration of a solution is the measure of the amount of solute that is dissolved in a given quantity, in a given quantity of solvent. A concentrated solution contains a large amount of solute. A dilute solution would be a small amount of solute. So we measure concentration. Most of the time in chemistry, you tend to use what we call molarity. Molarity, it has an R. Okay, there's another one with molality. But molarity is the number of moles in 1 liter of solution, and it describes the concentration of the solution. Molarity is moles per liter. Here we have this here, moles per liter of solution. So here we have a sample problem. A solution has a volume of 250 milliliters and contains 0.7 moles of sodium chloride. Now here is the molarity, is moles, okay, is equal to moles per 1 liter, okay, per liter. So here this particular problem, you're given moles, 0.7 moles, but we're not given liters, we're given 250 milliliters. So one way to convert milliliters to liters, we know 1 liter is equal to 1,000 milliliters. And so we times 1,000 there, divide by a liter. So the milliliters cancel out, and that gives us a liter. So then we would multiply 0.7 times 1,000 is 2.8. Another way you can do this, you can figure out milliliters. 250 milliliters is equal to 0.250 liters. And then you could do the same. Then you could just divide 0.70 moles divided by 0.250 liters. And that should give us the same, hopefully, answer. And it does. And this would be the molarity. So this would be the answer. That would be the concentration. And you have to remember moles per liter. Now sometimes some problems will not give you moles. You'll have to calculate the moles. Example, in this example. Calculate the molarity of a solution containing 400 grams of copper sulfate in 4 liters of solution. So remember molarity, put that here, molarity equals moles per liter. But they didn't give us moles, they gave us grams, so we have to calculate moles. Copper, we look up the mass of copper, 63.5. Sulfur, 32.06. We look at these from the periodic table, the molar mass, and we have 4 oxygens, so 4 times 16. We add these numbers up, and that gives us 159.6 grams. So 1 mole of copper is equal to 159.6. So the first step, we convert grams to moles. We have 400 grams. The grams cancel out, and that gives us moles, and then we we divide 400 times 1, divide by 159, so we have 2.51 moles. So that is dissolved in 4 liters of solution. So we divide by the 4, because the unit is liters, and this is the answer here. It would be 0.628 molar. Whoops. Can't lose the point. So that's the molarity. That's an example of molarity. And most likely you will be given something, you'll be given the grams and you'd have to find the moles, or you might not be given liters, you might be given milliliters, and you'd have to just, if it's milliliters, you move the decimal point over three places or divide by 1,000. A dilution. Okay, diluting a solution reduces the number of moles of solute per unit volume. So let's say you made up some Kool-Aid and you used a whole package of Kool-Aid in 1 quart of water. And the dilution would be, you would take maybe a 1/4 cup of that solution, put it in a separate container, and then add maybe another quart of water. That would be a dilution. And so what you would have here, molarity times volume, M1 and V1, one set, and the dilution would be M2, V2, molarity times volume. They would be equal. So this would be the initial values, the molarity and the volume, and then this would be the diluted values. You want less, more volume and less molarity. The molarity decreases. So essentially what you're doing is you have a solution, a stock solution. Okay, you have a stock solution here, and you take maybe 5 milliliters out and then put it in another cylinder here, this 5 milliliters, and you dilute it to 100 milliliters. And maybe this might be 10 molar. And then you took 5 milliliters out and diluted it, and so now it's not going to be 10 molar. Okay, it's going to be diluted. So we'll look at an example of this particular type of problem. How many milliliters of a 2 molar of magnesium sulfate must be diluted to prepare 100 milliliters of an aqueous 4 milliliters? So let's take a look at this, and let me underline. We have the initial, okay, M1 molarity is given this, and we're looking for how much of that solution we have, V1. They put a question mark there because that's what we're looking for. And then the second part, and I'll underline it in a different color, M2, we have 100 milliliters of 0.4 molar. So here we have the 100 milliliters of 0.4 molar. And you just plug the numbers in. 2 times M1 times V1 equals M2 times V2. So it would be 2 molars, and this is what we're looking for. Let's underline it in black color. Times 0.4 times 100. You want V by itself. Now let's just move this over and kind of show the math part. You have 2.00 times V1 equals 0.400 times 100. You want the V1 by itself, so you divide both sides by 2, and then you would do the math, and you get 20 milliliters. So you would take 20 milliliters out of the 2 molar solution, put it in a flask, dilute it to 100 milliliters, and you would have a 0.4 molar solution. And this is M1 times V1 equals M2 times V2. Molarity and volume. Molarity times volume. Let's flip back. Molarity times volume. Molarity times volume. And so here this would be the initials, the more concentrated, and this would be the dilute values. What you're diluting it to, and what's the new molarity. Here's another one. How many milliliters of a solution of 4 molar potassium iodide are needed to prepare? We have 250 milliliters of 0.6 molar, 0.76 molar. Again, this one, we're looking for V1, and these type of problems, you could be looking for anything, and they'll give you probably 3 out of 4. So you plug the numbers in. The hardest part is to make sure you have them paired right. So you have to carefully read a question. So here we have 250 milliliters of 0.76 molar. So that's one pair. Here we're looking for V1, and we have 4 molar. And so we would need 47.5 milliliters. Again, plug the numbers in. 4 equals 0.76 times 250 for V1, and you divide. Okay, you get V1 by itself. So it's molarity times volume, molarity times volume. The first M1 is the initial, and the M1 M2 V2 would be the diluted. Now the next is molality. This is different. Molality is a small m, and it is the concentration of a solution expressed as moles of solute per kilogram of solvent. Let's flip back. This is moles per liter of solution. So one is moles per liter, one is moles per kilogram. Two different things, molality. Moles of solvent, number of moles per mass of solvent, kilogram. That's molality. Again, here I have it, number of moles of solute per mass of solution, kilogram. A solution contains 17.1 grams of sugar, dissolves in 125 grams of water. Find the molal concentration. First step is to find moles. Okay, so this is the first step here. And here we find moles. We have 17.1 grams of sugar. Sugar is C6H12O6. And so we need the molar mass. 6 times the mass of carbon, 6 times 12 plus 12 times 1 plus 6 times 16. Okay, that gives us 180. So before you even start, you have to figure out the molar mass of sugar. We have grams here, we want grams down here. And that gives us moles. So we have 17.1 times 1 divided by 18 gives us 0.095 moles. And here we have moles per mass, kilogram. Well, we have 125 grams. 125 grams we can convert. We want grams. Here we have grams on the bottom. We want grams on the top. So it would be this times 1,000 divided by 1. Or 125 grams, if we divide it by 1,000, would give is equal to 0.125 kilograms. Okay, so some things you have to, so then we have 0.095 divided by 0.125. And the answer is 0.76. Little m is molal. That's with the L. Again, here, divide by grams, but we don't want grams. At the end, we want kilograms. So we know 1,000 grams equals 1 kilogram. Again, a conversion. Now here's a little opposite. You know, we still want these to cancel out. Since this is on the bottom, we want this on top. We have to know that 1 gram is 1,000 kilograms. Because this is in moles per kilogram. So going into the test, you should, you know, memorize 1 mole. A kilo is 1,000. So one kilogram is 1,000 grams. Then you use that convert. Either way. Again, if you see grams and it needs kilograms, you just move it to the left 3. And that's the end of this tutorial.